I'm not having fun.
Where's the
No,
music?
no
Where,
fun is had.
I thought I would get some music here.
where's Josh? Where's Dick?
They used to make this nice logo and everything. What happened?
They normally show up when the podcast begins.
There's this guy with the pirate hat that usually puts them on, and I don't know where he is today.
Welcome to the minimalistic stripped-down edition of the Scalawags. Our guest today is Martin Odersky from EPFL, inventor of the Scala language. You may have heard of him. And I'm Seth Tissue from Boston. Heather and Daniel, you want to introduce yourselves?
So I'm Daniel Spiewak from Boulder.
I'm Heather Miller, and I'm not from Switzerland, but I'm here now.
Yeah, that's fair.
Isère.
Easier. They call me Easier. Yeah, yes, that's my name.
Yes, well, this is a special Josh-less version of the Scalawags where we get to have fun or lack thereof without him because he is off on other business. Dick is also off on other business, so you get the three weakest supporting cast of Scalawags to interview our fantastic guest star here.
It's kind of like a sitcom spin-off.
It really is. It's like you take the least popular characters and you give them more contracts, and the other people are too expensive and they're making movies now, and like it's and then you put it in prime time and nobody watches it. That's what's happening now.
Somebody's gonna ask a question, I'm sure. Like up here and ask us something. I hope.
Yeah.
So, Martin, you're fresh off a trip speaking at Scala Exchange.
Yeah, I just came back from London yesterday. We had a good conference, quite a few people. I think they said about 600 people. And interesting talks and interesting conversations. I know that there was quite a big gap between a lot of intro talks, which is good, and then some very, very advanced talks that sort of were really pushing the limits of the type systems. So I hope that people didn't fall into a big hole between those two kind of talks. But no, I think overall it went well.
Well, that kind of happens. I think that happens every year at like any Scala, for example, where there'll be a couple of intro talks, and there'll be like something insane that Miles is doing, and then it'll be back to like intro talks, and then I think people actually, at least my experience has been, that people go to these conferences and yeah, like if they're really new to the language, they'll be just completely overwhelmed by the advanced talks, but it doesn't really drive them away or make them sit on Facebook longer. It's just, it seems that it's like, okay, I have no idea what's going on, but they seem excited about it, so it's probably cool, and I'll pay attention and maybe Google some more later. And I think that can be really, really good for newcomers to a concept.
That's true. Yeah. No, I don't think there were any people who were complaining or anything like that. So I just noted that there was a big gap, and also that I think the community as a whole is becoming more specialized. So now it's no longer about Scala, but Scala plus libraries like Scala Z or Shapeless or things like that, and that's becoming sort of, for some tracks, that's becoming sort of standard knowledge that you're supposed to have before you go into the talk. But I think it's just a sign of maturity that we have been around for a while, and we have developed like very interesting subcultures, and now these are all sort of in the conference.
How many people were in attendance? Like, how big of an event was it?
It was about 600.
Okay,
So
it's pretty big.
yeah.
That's a lot bigger than the year that I went. I think the year that I went, it was like in a basement somewhere, and it was like, what, 50 people, something like
I
that?
remember you. Yeah. About what was it? Compiler. How that all we do about compiler construction is wrong, or something like that. It wasn't the
Yeah, exactly.
Yeah.
I've since modified my views on that one, but it was an interesting talk to give, and it was a fun kind of rabbit hole to go down.
Right. Yeah. That was in the crypt. That's where they had reactive days as well. So it's sort of one step up from the skills matter premises, which hold even less.
Mm-hmm.
But now we were in the so-called Business Design Center, and that's huge. So they told us that next year they could double the attendance if so many people come. But the premises are big enough, and it was spacious, and it was good. So everybody had lots of space also for side talks and things like that.
That's fantastic.
Yeah.
So can you tell us about your keynote about this proposal for finding a middle path, I guess, between distributing software as source and distributing it as binaries.
Yeah, so I was, of course, thinking for a long time about binary compatibility or the lack thereof and all the problems that makes, because it's really something that has been, I would say, pestering us for years, many years now. So, and initially there was this feeling of guilt to say, well, obviously we're not disciplined enough, so change things around all the time. We shouldn't be so naughty. We shouldn't do that. We should be just more disciplined, and the binary compatibility problem will go away. Only it didn't. It didn't really. So essentially, every release we do, we have to be super careful not to break binary compatibility. I mean, now we have this MIMR tool, which helps a lot. So at least we know when we break it most of the times. But still, that means that for minor releases, we now have the policy that we can't break binary compatibility either backwards or forwards. And that is a huge toll to pay for, first, the time it all takes to think about these things, to consider them, and secondly, for the bugs we cannot fix in time, because we just have to wait because they might break binary compatibility. So this is all, of course, very difficult. And then the observation was, well, why it doesn't seem to be a huge problem in other language communities? Why not? So in Java, it's not a problem, of course, because, well, Java is really, compared to Scala, much less than syntactic sugar on top of the JVM. So innovation and changes happen under the bytecode boundary, so in the JVM. For instance, if Java wants to add traits, our analog of traits, well, they change the JVM to support default methods, and that fixes the binary compatibility problem for them. And a lot of other things you can change in the JVM. But of course, we don't have that option. And then, I mean, there are a couple of outliers, but then most of the other languages really built from source. And so, by definition, they don't have a binary compatibility problem. If you build from source, then you're okay. So then the observation or the question I was asking myself for a year now is, well, why don't we build from source? Let's just be radical and let's say Scala should build from source. But the problem with that is that we don't really have a standard build process. We don't even know which build tool to use, SPT or Maven or Ant or Gradle. I mean, we are completely split about what build tool to use. And I guess even if we could standardize on a build tool, truly reproducible builds are actually quite rare. Because we don't have to. We don't have to make our builds reproducible because everybody's using binary, right? So it's sort of a chicken and egg problem to say, well, people don't invest in reproducible builds because everything is binary, and therefore you can't build from source because the builds are not reproducible. So that's sort of the conundrum we are in, and that's why I think it isn't really a lack of discipline in the Scala community, but this particular situation we find ourselves in, that we're sort of living on the JVM. We have a very sophisticated compilation pipeline, and lots of things are happening there. Lots of things can break, and I would say should break if you fix the bugs. But then we have the binary compatibility problem. And the proposal I had that was essentially to use typed ASTs, so typed abstract syntax trees, as essentially the interchange format for Scala code. The advantage of that is that once you have typed trees, essentially all the things that can go wrong already are behind you. So very few things can go wrong once you have them, because then it's very straightforward and completely deterministic to map these typed trees into bytecode. Whereas if you build from source, then you have fun things like what classes do I have on the class path? How does it affect my implicit scope? How do I do overloading resolution? What is the precise bug for bug compatibility in the compiler corresponding to implicit search? Because I mean, that changes. We do find bugs, we fix bugs, and my observation was that every time we fix some bugs in implicit search, shapeless breaks. because it already made use of the bug before. so these sort of things, once you have type trees, they're no longer an issue. It's very simple to go from type trees to bytecode. And at the same time, type trees are essentially capture all the semantic context of Scala programs. So they cannot really cause any binary incompatibilities. So the proposal then is we map source files to type trees and then type trees to bytecode or whatever backend we have. Could also be JavaScript or some other backend. And then when we rebuild some stuff and we have a library that is outdated, let's say we have built some library against 2.10 and now we want to rebuild against 2.11, so this library is still built against 2.10, then we have the type trees of that library. And that means it's possible to automatically just take the type trees and remap them onto Scala 2.11 or whatever the latest version is and have a build that is consistent again. So I think that this would be a great progress that we would essentially need to do one big jump, a new interchange format, and that would fix the binary compatibility problem pretty much for good.
So there's a lot of interesting stuff in there. Like I don't even know if I should just like begin chronologically with my thoughts because I have like a small volume currently.
Do it.
All right. So thing number one, going back to the like source versus binary distribution and things like that. Isn't this, you know, are we running in danger of kind of rehashing the old autoconf days and like, you know, C distributions where you have to like do make files and things like that, like, and your make files are auto-generated by scripts that are auto-generated by scripts that read your system, like you know, these are, source distribution is not necessarily a panacea of compatibility, and it's certainly, and things in that direction, and it's stuff that's been tried before in a lot of ways, and we moved away from it for good reasons. So I mean, I guess typed ASTs kind of are a little bit different, but I don't know. That was just my first thought when you said, well, you know, source distribution, yay, and standard build tools.
Yeah. I think the point is that type trees are actually for the purposes of builds are a lot different from sources because, like I said, all the things that can go wrong really do go wrong when you go from source to type trees, and afterwards, essentially, it's completely reproducible and deterministic. Yeah. So in a sense, type trees are just a Scala-specific bytecode format that happens to capture the Scala semantics better than Java bytecode, and therefore that wouldn't introduce spurious changes when you, let's say, add a new concrete method to a trait, where then you have to fix it up in all the implementing objects. So that's a thing that essentially affects the bytecode, but it wouldn't affect the type tree at all, because in the type tree you would say, well, trait has new method, and actually implementing this method, so doing all these fix-ups, that happens afterwards. That happens in the backend. That takes the type trees and spits out the bytecode. So for that, I think it's much. It's really sort of. You could say there's nothing much new. I mean, even now we produce class files on the JVM, and we add these Scala signature annotations, which essentially give you the Scala view of all the symbols that existed that are reachable from the top. And what you would do now is we would just include with the symbols the trees. The tricky bit is
so you would actually produce Java bytecode that has the Scala intermediate language, if you will, like embedded as annotations, or would you actually produce files that are completely unambiguously binary Scala files?
I think it doesn't really matter, but my inclination would be to just continue what we do now, to just keep them as annotations in the .class file.
Well, the problem with that, though, is you actually have to produce bytecode, or with which to to which you attach your annotations, right? So you're already sort of doing part of the compilation process and making some commitments. Does that bytecode have any meaning, or is it sort of half compiled? Like, what does that bytecode do then?
Well, no, the bytecode would have meaning. That would essentially, when you compile, you have a preferred compilation target. Let's say it's JVM Java 8. Let's say. Then what you do is you produce the bytecode as now. You just keep the fully typed tree in the class file, so that if this thing ever should become outdated, then it can be recomputed using the type tree. That's all. But the
Oh, I
compilation
see.
pipeline is exactly as before. It's just that the type tree, they will add some bulk to your class files. That's a major downside that I see with this whole thing, that the type trees, they can become rather large, and one of the technical challenges is to make them compact.
So this then avoids the issue where we have, Scala libraries that are distributed, some of them distributed as jars because, maybe people are on the old format or, they care about Java compatibility or something like that. And then some Scala libraries that are distributed as like SARs or something like that, which have, Scala specific bytecode and
Yeah.
diseases that they bring and
Yeah. There's
yeah.
another reason why it's good to do that, and that's that actually some of the compile time errors are detected only later in the pipeline. So, for instance, there's this infamous, these two members have the same erasure and therefore you can't have them. That's detected during erasure, which is very much part of the backend. So what you want to do is when you first compile a source, you really want to compile it all the way down, at least way past erasure, so that you get all the possible errors immediately, and not only when you build a client or you link, so to speak. So for that reason, I would say let's just go immediately to bytecode, but keep the trees around as a distribution format. And I should say that these type trees, they have lots of other uses as well. So one is, of course, optimization. With type trees, it will be really easy to inline. And furthermore, you can inline without breaking binary compatibility. That's a nice thing. If the type tree changes, then you just recompile, right? And secondly, it's also great for program analysis, like bug finders and things like that, because you really have a lot of these bug finding tools. They struggle to, again, get reproducible builds to even be able to sort of spin up a compiler so that you can pull out some information from the things. And here it would be right in your face that type trees would be simply in the class files already.
So now from a practical standpoint, just to clarify for myself and the audience, then these class files that would be produced that have the annotations, the typed trees, they would be full-fledged class files. You could load them just like we always have. Throw them in the class path, read them from Java, whatever. It's just going to work. You don't have to do a separate compilation step. But when you're compiling against these things, and you say are compiling a class that mixes in a trait, or even worse, a trait that mixes in a trait from this library, your Scala C, when it's compiling your code, can use those type trees to do things that it can't do right now with just bytecode, and will produce better class files output.
The Scala C actually has to work even now. So I think Scala C could profit for optimizations. But for correctness, of course, it has to work even now with separate compilation. So it would be, I think the feature would be more in a build tool like SPT, or I guess one could make these things also available for other build tools like what we do now with the Zinc incremental compiler. So the idea would be that if SPT says, well, I rebuild a top-level file, it would track all the dependencies. It would say, well, is any of my dependencies outdated? So I would keep hashes with these files, and it would say, well, is any of my dependencies outdated? And in which case I have to recompile that. Even if the file, I don't have the sources, I have the binary, then I can still recompile because I have the type tree. It's even preferable to recompile with the type tree because we know that will succeed with much higher likelihood than source.
Okay. I think that makes a lot of sense. Then, if I can put on my enterprise hat for a second, a lot of people will produce application binaries and even surprisingly commonly library binaries, which are obfuscated outside of the public signatures. Would you just have a mode that would disable the emission of type trees? Because clearly, if you're obfuscating your code, you don't want the trees in there.
Yeah, of course, yeah. No, I think there could be a very simple tool that would just strip the attribute from a class file. And I think that tool would make even sense now, because even now with the attribute that just tells you what essentially the public API of this thing is, that could also give you some info. So if you just want to run them and not compile against these things, you can strip it away.
Interesting.
If you take a step back from this, I think this whole idea is really exciting, and it ought to seem. It actually ought to seem very natural to us. Like, it seems like a very different way of distributing software, but it's the old way. It's the usual way that should seem strange, because it dates from a different era when distributing software, the disks were smaller, machines were smaller, code was proprietary most of the time, and so the important thing was to ship a binary that was as small as possible and had as little information in it as possible. And I would say that this should actually seem strange to us. The normal way that we should receive a piece of software, it should come with a complete pedigree of here is the source code that it started from, here's the documentation, here, and perhaps optionally there would be a build product that could be type tree, it could be bytecode, could be both. This should all come together. Why would we trust something that just came to us without all this stuff along with it as a unit? I hope that will come to seem normal.
Well, there's a lot of different use cases, though. I mean, think about all the people who are doing MapReduce on enormous clusters and things like that. When you ship this updated jar file around to your different nodes in your 100,000 node cluster or something at Yahoo, the last thing you want is to be adding another megabyte to that jar.
I was just going to bring
that megabyte becomes gigabytes and terabytes as you're sending it around.
Yeah.
Sure. So throwing away the stuff that you don't need in a particular context, that should be an optimization rather than the default.
It could be looked at almost like minimizing, CSS or JavaScript or something, that or like the developer-friendly version, right? Like we already kind of do this in web development land. I mean, we could also look at it like this, sort of JVM binary land, right? I don't know.
Because if you really want to minimize, you probably also want to strip like line numbers for debug info. You want to strip, like I said, the Scala attribute that we have now with the symbol infos and things like that. I mean, there's a lot of stuff that's not strictly necessary for running the jars. Yeah. But it's trivial to strip them from a class file.
But I mean, like it would be basically equivalent to having maybe like a development version and like a production version, right? So I mean, once you've developed libraries on top of something that already has these sort of type trees, then I guess you could throw them away when you like recompile and ship something that you believe is production ready.
Yeah. So the other related concern to that, actually, from a space standpoint, is loading classes in some applications, especially Scala applications where there are a lot of classes, is often a non-trivial overhead, especially for startup, but even while you're running your application, early in the warm-up cycle. And managing all of that memory can be a non-trivial cost for the JVM. I mean, even in Java 8, where PermGen is a little bit more streamlined, and there's some nice things with that. Like, it's still not cheap to bloat up your classes. So, I don't know. I mean, I guess that could similarly be a production mode. I'm just thinking back to Precog, where I remember we did some benchmarking, and we found that when we did compile stripping the line information, stripping the symbol information, things like that, we had like literally stopwatch measurable increases in our performance of our application, just because all of our bajillions of classes were that much smaller.
Yeah.
So I think that sort of thing will become more important if this is implemented.
That's probably true. Yeah. So one thing to notice that here the tree would only be in the essentially class file that represents a top level class. So there would be relatively few class files that have the trees in them, because it would be the tree for the whole top-level class, including all inner classes. But then those class files that do have trees in them have really humongous trees in them. But it's not sort of a tax you pay for every class that you load, because a lot of these classes would be inner classes or classes coming from closures or things like that.
Oh, okay.
But it could still.
Okay, that is a lot better then.
Yeah, I guess, yeah. Also, I guess PermGen is probably the stuff that the JVM loads, right? That's not the class files. That's the stuff that the JVM, the internal structure that represents the class files. And again, those I'm not sure. Well, the JVM probably would keep the attribute, so that's an issue. Yeah, I think.
Yeah, I think the attributes have to be retained.
Yeah. Well, no. There's a thing. There's Isn't there an annotation that says runtime annotation?
I think I think the compile time annotations still have to be loaded though, because otherwise you wouldn't have any access to them. Well, I guess maybe. Do you only have access to compile time annotations from like APT and compilers and things?
I would assume that compile time annotations don't need to be loaded because you can't get at them with reflection.
This shows how often I use this particular function. But yeah, that does make sense.
Yeah, I think that's true. Kind of by definition, it's compile time.
Yeah.
So if the Scala signature annotation is a compile time annotation, then we might be okay there. I mean, the bytecode reader still has to pass over it and still has to validate it, and it still takes time.
That's
but
actually
it might not actually need memory.
Because I think because we need, so the current one we need for reflection, so it must be a runtime annotation. But the question is, would we need the trees for reflection, and what's the price for that? So that's a question we have to figure out. Yeah.
Yeah, and I could see some use cases where the trees could be really, really valuable for reflection, but I mean, I think a lot of applications probably wouldn't take advantage of that. And so again, having a mode where you can turn it on or turn it off would be really, really nice.
So we're starting to get a few questions from viewers. Heather, this is a question for you that you need to answer extremely carefully. To Heather, what is it like doing PhD under legendary Martin Odersky?
It's fun. No. Sometimes you have to do some teaching that can be not fun. Other times it's lots of fun. I mean, there's lots of stuff going on, so obviously it's a very fun PhD. I'd rather be doing a PhD in this than like be doing something in info theory where I'm just compressing things. So, I mean, this is very interesting, very exciting. I mean, everybody who's probably listening to the podcast probably thinks Scala is exciting for some reason, so if you get to work on it, awesome. It's great. It's fun. But every job has its drawbacks, and, some stuff is not fun, like, maybe some teaching at, grading exams is never fun, ever, but yeah, everybody's job has some unfun parts.
I saw you just had a grade sheet this afternoon, no? On your computer. What was that?
Oh, yeah. Sheet? That was the grade sheet for the last assignment that the in course at EPFL students for their new assignment that they were submitting, and it was great. Lots of zeros all the way down. I don't know, what did we do wrong? Yeah.
It's one of those moments where you panic. You see the metrics go down, and you're like, "Oh, I wonder if maybe the assignment was too hard, or maybe I didn't explain something." Or
well, there's always the student that doesn't really come to the lectures, or somehow manage to nab some other students' assignments, and then they'll show up towards the end of the course and ask a question where you're like, "Have you ever come to the course? How could you ask?" I mean, I'm not gonna say any of these things. But I mean, you just go like this. You're like, how do I even answer this? I want to be nice to you, but I don't want you to be upset with me for being read the book, read all. How do you not know this? You have to somehow help them know something that they should have learned in week 1. And some of these things are a little bit tricky and frustrating, but otherwise, grading sucks.
Yeah, it does. So I had when I took my advanced compilers course from my favorite professor. It was one of those courses where you're dealing with material which is beyond what any of the books are. So it was mostly just technically an undergrad/grad course where we were all just reading papers and writing optimizing compilers and fun stuff like that. But because it was he had taught the course maybe 3 times because it's one of those very specialized things that can only come around every few years, and one of the assignments, in the middle of the semester, was just insane. I can't remember exactly what it was. I think it was something we were building. Oh yeah. So we were building an optimizing compiler for a subset of Scala, and we were writing it in C.
Oh, wow. So sorry.
Yeah. And I forget exactly. Oh, I remember what we were optimizing. Oh, okay. So this particular subset of Scala, we had we weren't doing separate compilations. So this was fantastic. We have all the source, we can just do whatever we want. And so what we were doing was polymorphic inlining.
Oh wow.
So we had OO, right? But we were doing polymorphic inlining in this compiler, and so you have like all these picks that you have to compute, and there were like these various papers that we had for like coloring and following and things like that, and all of these really really exciting and utterly fascinating things. But like the assignment was basically to implement this for the entire subset of the language that we were implementing, which was about the subset of the language that corresponds to like basic Java plus some ML, if you think about that subset of Scala, right? And it was just it was so fun. But I think I probably put like 30 or 40 hours into it, and then I sent him an email, and I'm like, I haven't been slacking, but I'm like not even a third done with this yet, and the deadline is here, and I have no idea how the other students are doing, but this is not happening. And so he ended up doing something like really generous with the grades and like doubled the deadline or something like that, because he just didn't realize that it was going to take so long. Like he sat down and did the assignment, and he was like, "Oh,
you're right.
That's really hard."
Yeah, we just did that this week, actually. I mean, not that assignment, obviously, but had the same overall effect. We gave them something that was like, it took us a few days to put it together, and we're like, this is cool. And then we gave students, their second-year bachelor students, their first semester. So it's like their semester 3 of undergrad, and then we gave them like some like super hard constraint solving problem, and it was like many parts, and it was too long for they just had a nervous breakdown when they got it. They had like the same thing where they couldn't get it done in the time we gave them. We gave them like 1 week, and they were like, "No, my God!" Yeah, like, exactly the same thing happened this week, basically. So,
that's terrible.
Yeah.
But didn't you find it cruel to have to write a compiler in C?
Yeah, that's pretty bad.
I really loved it. Okay, so for one thing, like I have this dark fetish for C and C++ because it's like, okay, you could do terrible things to yourself, and it's like being on drugs, right? You're doing terrible things to yourself, but it's sort of fun while you're doing it, and like there's all this dark power that you have access to that's normally sort of forbidden magic, and like all of that is really really neat. And I mean, we got to play some really crazy shortcuts, right? So one of the things that we were told at the beginning of the intro compilers course, where in the intro compilers course, we went through every single stage of the compiler, and we implemented it all front to back, basically, in the course of a semester for the same language. But we were basically told, okay, we're doing this in C and C++. Forget memory management. Like, don't worry about freeing anything. Like, if I see a free in your code,
just allocate.
Yeah, exactly. So
That's
this was
awesome.
fantastic. Like we had some bugs where I would get like core dumps that were 4 gigabytes in size because it just allocated the whole memory and then crashed the 32-bit image. But it was really really good, and I learned a lot of stuff about like some dirty tricks that you can play when you're writing compilers without like really high level constraints. And it also means that when I started writing compilers in higher level languages, especially functional languages, it just felt like a vacation on the Riviera, because it was so easy to do some of these things that I used to struggle with.
I would have much preferred to write a compiler for a subset of C in Scala than the other way around.
Yeah. Well, so the reason he chose a subset of Scala, it was originally, like, this was a language that Alex Aiken originally created and then eventually morphed into a subset of Scala. But they wanted to contrive a language that had object-oriented functionality, so you have to deal with inheritance hierarchies and things like that.
Was it called Cool?
It was called Cool.
Cool, yeah.
Yep. Yeah, so Cool has now become very much like a tiny subset of Scala.
Okay, yeah.
Mostly through syntactic changes, but some semantics have been modified as well. I think there's still some weird stuff in there that is actually divergent from Scala, where like equality operators don't work quite the way they do in Scala and things like that. And there's like some stuff that doesn't parse the way you would expect it to. But for the most part, you can take modern Cool files or school and compile and run them as Scala.
Okay.
Anyway, so it's a subset. It's a tiny little contrived language that has you have object-oriented capabilities. So your students have to deal with inheritance hierarchies and inheriting functions and things like that. No overloading, but and then have some functional constructs as well, and just various things, simplified mathematics and conditionals and whatnot. So it's got enough meat to it that you do have to deal with non-trivial stuff, especially in the back end and especially in the typer. You get to see the interaction between the typer and the namer that OO kind of screws up. But I don't know. It's a pretty good language to target, I think. It's certainly a lot better than all of these courses that are like, we're going to compile Java, and oh, okay, well, so there's like, you will get 90% of the way there, and then there's like this 10% that's incredibly hard.
Yeah, yeah.
So the next viewer question actually kind of stays on the compiler theme. Pablo Perez asks, concerning bytecode, is there any plan to support, again, the .NET bytecode as compilation target? And I'd like to invite you to broaden that a little and maybe also talk about other targets like ScalaJS or anything else that you might have in mind as a possible future target.
Okay. Well, it really depends a lot on the community because these things are community driven. So somebody or some group of people has to step up and say, well, look, we really want to have a backend for Scala for this platform, so we're going to work on it and build one and make sure that the ecosystem exists and things like that. I think that's what our initial mistake on the .NET front was, that essentially it was a project we did with Microsoft that was in part funded by them, and we said, well, good idea, let's do that. But there was no community. There wasn't really a community pool of people who said, well, let's contribute this module here and that library here. So in the end, it became sterile. It was just an exercise, you could say. And I want to avoid that in the future. So in the future, with whatever we do, there must be a community that says, well, we really want that. We're interested in that. And I think the ScalaJS shows that what the things you can do with even a small community. I'm completely in awe of what the people in the ScalaJS community have achieved so far, and also how much fun they're having with it. So ScalaJS is absolutely a great example of this sort of community-driven development.
They even have a book.
Sorry?
They even have a really nice book.
Yes, they even have a really nice book. Yeah.
Like way better than any book that I've seen written in such a short time. Oh my God, amazing.
Well, so talking to like Jeff Reedy, for example, who was working on the LLVM backend for Scala, it sounds like actually doing the compiler backend really isn't that hard because you just compile to a different output target. You know, the intermediate format for Scala isn't really that terrible, but it sounds like the biggest problem is like so much of the semantics of the Scala standard library are just C Java, right? Scala strings are Java strings. They're not other strings. They don't have defined semantics of their own. They're just Java strings. So, is there any plans in future to maybe make that better in some ways, like through some abstraction layers or something like that? Something that would give Scala its own core identity that would be a little bit easier to implement than all of the Java standard library.
Yeah, that would be. It's quite possible, and I think it has to be bottom-up driven. So essentially, if we have separate platforms like ScalaJS, then we can have a look at essentially what do they need, and they actually need it surprisingly little. So they do identify string with JavaScript strings, and they implement the right machinery with just decorators and things like that. So you just add slap methods onto JavaScript things. There's one tiny little thing in the language that they needed, which makes sense, and I think we decided that we want to do this addition do this change in main Scala as well, and that has to do with pattern matching numeric types. So you have, let's say, an object, and you want to say, well, is it a byte? So you say case x : byte, and previously it was a byte if it was created as a byte, and what JavaScript would really like is it's a byte if it fits in the byte range.
Oh.
Because otherwise they'd have to box all the numeric types, and of course that's terrible because in JavaScript they're boxed anyway. They're all numbers, right? So they'd have to box over box, and that's of course a big performance hit. So that was like a tiny little twist, but I think it actually makes sense. It should simplify the language. Right? I think that's my phone. I just take this.
Welcome to the intermission for the Scalawags.
Okay,
I'm Daniel.
All right.
Okay. The intermission is over.
Yeah. So,
yeah.
I have a follow-up question about ScalaJS. Most of the traction that functional programming has gotten so far, and that Scala in particular has gotten so far, is on the server. It's on the back end.
Okay.
Moment. Hold on.
Okay.
the phone, like one goes to the other one. You know, so 1 second.
Someone entertain us, Daniel. Where's the cat, Daniel?
Oh no! Yes, turn this into another internet cat podcast.
It's always like degrade into a cat podcast.
Right. Yeah.
So is that your question?
Oh, okay. So far, the inroads that Scala has made, the inroads that functional programming in general have made, have been mostly on the server, mostly on the back end. There hasn't been a lot of commercial adoption of using functional programming to make user interfaces to do front end work. Is that just a historical accident, or is there a more fundamental reason for it? And the context being that I think ScalaJS is really a hopeful sign that this might be on the verge of beginning to change.
Yeah, I think it's a historical accident that you saved the front-end languages, so the languages in the browser, they were always sort of more ad hoc. What Brendan Eich said, he wrote JavaScript in 12 days or something like that. It just had to be fast. So there haven't been that much thought that went into them, and also it's fairly young. I mean, these things, they move very at a glacial pace usually. I think that functional programming makes a lot of sense, in particular functional reactive programming on the front end. So if you could actually describe your UI as essentially a relation from what your model is and what you're seeing, that would be liberating. You wouldn't have to do all these updates anymore and so on. So I think there's a big, I mean, sort of what the React is for the Facebook library, or Angular is a little bit like that as well.
There's a whole bunch of these JavaScript libraries that are kind of coming out with this, like, functional idea, and these FRP ideas, like in the JavaScript libraries. I mean, in the last 1 or 2 years, it's kind of sort of exploded, hasn't it? At least in JavaScript land.
Yeah.
Well, actually, not even just in JavaScript land. So if you do any iOS development, the frameworks that Apple provides for doing UIs, depending on which framework you're using and whether you're on Mac or actually iOS, but just doing Cocoa stuff, there's a lot of places where it approaches FRP. And they're not trying to be rigorous about it. They're just trying to make things easier and better. And this is just, I mean, they're very aware of these technologies, and they're taking advantage of them. So I think I think you're absolutely right, Martin. I mean, FRP is a fantastic way of doing front ends. It's just that people haven't done it because they're like, ooh, the DOM, press buttons, make things happen, change attributes on the DOM, and then yeah, nothing moves beyond that. We've built technology that's fantastic for making things blink, and then that, like, we just stopped there. We just need to keep moving.
Yeah. The other sell is whether we can sell types to the front-end people. That's the
oh my God,
sell, right? Right,
how much time do you spend debugging some weird, like, runtime, or, well, obviously runtime, but some, like, weird, I don't know what this is, I think it's an object JavaScript error. Like, I don't know why people don't realize that, it'd be wonderful to have types to get rid of these issues, like,
So the funny thing with JavaScript is when I actually write JavaScript, I use it, obviously it's untyped, but I use it much more like an OCaml than anything else. I'm using it very functionally, but I'm taking advantage of the record polymorphism very, very extensively. And I don't really use prototyping because prototypes in JavaScript are incredibly weird. But the records and the record polymorphism is incredibly valuable to me. So I don't know. I mean, I guess on the one hand, maybe types would probably help there. They certainly help in OCaml. But I don't know. I don't spend much time looking at something in JavaScript trying to figure out what type is this, because I really care about, well, does it actually have this function? And that's actually very easy to figure out.
Yeah.
Yeah, but sometimes you have some weird state machine that gets some like wrong object of some kind, and something just like an interface just stops working completely.
Yeah.
And you only find that out when, like, some user clicks like this button, that button, and that button. And wouldn't it be nice if we had some way to, like, avoid that issue, like, altogether, because you don't find that out until 6 months later. Oh yeah, users have been doing this thing where they get into this weird state that you didn't realize could happen, and then you pass a weird object to it, and it's not the object it expects, and everything just crashes and it just hangs, right? I mean,
yeah. Well, I think that this is even worse for JavaScript developers than it is for users of other dynamic languages, right? Because other dynamic languages tend to have this culture of, we're going to test the heck out of everything, right?
Yeah.
Dynamic languages tend to say, well, tests are just a poor man, or types are just a poor man's unit test, so we're just going to have a lot of unit tests, and usually they do. But JavaScript developers, I mean, not the good ones, but like a lot of JavaScript developers, most of them, I would hazard to say, just don't write tests. They're like, oh, okay, well, I clicked the button once, and it made the thing do this thing once in a clean slate when I hit refresh. Okay, well, we're good. We can ship it now.
Your choices are what? Selenium, right? I mean,
I think there are actually a couple of different testing frameworks, because I know I've used more than one.
It's just a bit clunky, that's all. Like, so, I mean, setting up and using Selenium and like making Selenium tests is a little bit crazy, and then running them where you have like this very funny situation where the browser pops up and it starts doing all this, and I mean it uses a bunch of resources and whatnot. So,
well, the point is actually to test it the way we do, like, so if you've ever done Swing development, right?
Mm-hmm.
You don't test a Swing application by having some sort of like auto clicker go through and click buttons in Swing. No, what you do is your UI logic, your front end logic is relatively contained. And you try to keep it as simple and straightforward pipelining as possible. And then all of the other logic is stubbable, and you can put it in a unit test suite. So the best JavaScript developers that I've seen do that, where their JavaScript, like the actual serious logic of the JavaScript, is completely isolated and separated. And you can just feed in, you can take advantage of the record polymorphism and just feed in objects that have the right stuff that will be UI plumbing eventually, but aren't UI plumbing now. And then you just run it in a test suite, and there are some really, really, really nice JavaScript unit test frameworks that can do things like that. And then you just wire it up very simply to the front end and hope that there are no bugs there. But
right. You still might want to use something like Selenium for having a few sort of end-to-end tests that basic functionality is there, but
it's like an integration test.
Right. I don't think anyone writes that kind of tests to the level of granularity that they do for more traditional unit tests.
Yeah, but I don't know. I mean, I love types. Like in terms of selling types to me, you're sort of preaching to the choir. I think the more interesting problem is getting people to recognize that types can really help you reason about things, and types can be that extra layer of reinforcement in when you have structured your problem correctly. That's basically what my any Scala talk last year was all about. It's like, okay, well, think about your problem in terms of data. Think about it in terms of these data structures, and like, structure your problem in your data domain carefully, and then your types will constrain everything, and it will work perfectly. But you need to constrain yourself carefully.
Yeah.
So the next viewer question is about the type level Scala. Dan Osipov asks, what are your thoughts on merging type-level fork changes into Scala without breaking backward compatibility?
Right. So, well, so far, actually, the type-level policy is that they wouldn't break backward compatibility. So, as long as that's the type-level policy, merging them back into Scala shouldn't, by definition, present any problems for backwards compatibility. If that changes, then we'd have to have some hard thinking to do. But I don't see it changing, at least for the moment. I think we are working together very well on that one. So generally, I think I'm quite positive about the type level thing, because it lets us prototype things much faster than we can do in standard Scala because of all the binary compatibility requirements. The horizon to put anything in standard Scala is measured in years now. So, well, if you propose something today, then if you're lucky, it will be in standard Scala in 2 years, but not before that. So type level, of course, can move much faster, and that's a good thing, because it lets us essentially try out things and then hopefully take the best ones back into standard Scala. The other thing is that actually type-safe, so JSON and Adrian and type-safe, are actually contributing a lot to the type level thing, both in terms of solutions, pull requests, and also in terms of reviews. So there's a very healthy and good interaction between essentially the two communities, the standard Scala team and Scala compiler team and the type level team. So all this is very positive, I think.
So with respect to the compatibility thing, just a note, the the type level people and well, the type level project actually has been in the process of discovering just how hard it is to actually do things in the Scala language without touching compatibility. Like there's some of these things are just so incredibly innocuous. Like I think Eric Usheim added another numerical suffix, right? So you could have actual real byte literals. And I think the suffix is X or something like that. So it's like it's not something that conflicts with Scala, right? All of those things. It's all great, right? And then the problem being, of course, that Scala, if you do 42x in Scala, Scala will parse that as a suffix method X on the number 42.
Oh.
So,
yeah.
So it's terrible. Like the thing that really shouldn't conflict, it actually conflicts. Surprise. And another problem happened with we were trying to do the type lambdas.
Yeah.
And using the goal was to use the syntax for type lambdas that's been proposed for Dotty and for Scala 3.0 and like all of those things, right? And because it's a fantastic syntax and it works and it's great and it solves so many problems, but it turns out that there's some weird corner cases with the type parsing that it actually does break source compatibility. So we can't put it in without hiding it behind a flag. So it's just it's strange. Like even these things, like you look at it, and it's like there's no possible way that conflicts. Oh, Scala finds a way to make it conflict.
Yeah.
So basically everything has been hidden behind flags thus far. I don't think anything has gone into the bare language.
Right. Yeah. Well, I think one has to be a little bit pragmatic there. So, for instance, with the suffix for the byte literals, I guess one would probably wants to see whether there's any actual Scala code out there. I mean, really, not just test code to just exhibit that feature, but real Scala code out there that would break. And I think the community build actually is a pretty good benchmark for that. So what I would propose is let's try the change, run it through the community build to, 1.4 million lines of code, some in community projects now. And if they pass, then we declare it innocuous, a change.
Yeah.
And if anybody else's code breaks, then, well, that's just to write Scala in a completely pathetic way. And
yeah, well, I think that's a fair way to define it, though it's definitely more relaxed than what the type level team has set out for themselves. I mean, the type level team basically said, if there's any way you can contrive source that compiles differently in Scala C than compiles in TLC, then something has gone wrong, and we did something wrong.
Oh yeah. All right, yeah, but I mean, these things are really sort of, I would say, maybe academic is the right word. So as long as there's not actual code out there, or we can realistically assume there's not actual code out there, I would be pretty relaxed about that. There's one other thing that concerns me a bit more, let's say about byte literals or whatever, is that I really want to keep the language small. So essentially have everybody's favorite feature, shove them all into Scala. That's probably not what we're gonna backport into the main language.
No.
That would be too big a language. So, but there again, I think if type level has a different philosophy, that's not bad, because then we can actually see all these features in the wild, and then maybe some are much more popular than others, and then those would be more natural candidates for possible inclusion. So again, it's not bad to have another arena where these things can be tried out.
So maybe we can actually move on to some other user questions. There was one about Coursera, actually, and I want to also take this into a direction and ask some more questions about community. But first, Jatin Puri, I'm not sure if I say this, Yatin Puri, asks to Martin, apart from the two different courses on Coursera, which Yatin really seems to like. Yes, thank you. Do you plan on any other courses, or do you plan on anything else?
Well, actually, we two, I have been talking about a potential third course, which would be more in the area of parallel programming, parallel transformations, and both in the in the parallel case and the distributed case. So essentially from parallel collections to Spark, covering that domain. And that's very, very early stages, so we're not sure yet we're going to do it, and we're not sure yet when, if we're going to do it, when it would come out, but there's sort of some initial thoughts of maybe that would make a nice course. That's the current state.
Like data parallelism rather than like reactive stuff.
That's right, yeah, yeah. So essentially, don't...
tangent parallel sort of thing.
Yeah.
Not tangent parallel, okay, that doesn't make sense, but you know what I mean. So actually I want to that's kind of in the same direction, also a little bit as some of the other sort of things that we were hoping to ask about Scala community. So I mean, this kind of fits into sort of like, I don't know, growing knowledge in the community and whatnot. And I mean, so maybe the next question that's not a user question is, like, what about the Scala community? What should we be doing? What are we not doing? What, you know, is there something that we can say about, like, you know, where the community is and where it's heading? Are we doing the right things? We can get more specific, but maybe ask, like, you know, what sort of, how is it now and what changes would you like to see, maybe more specifically? Do you have some sort of opinion or thought about the Scala community, or should I make that more precise?
Yeah.
Sorry.
Well, it was a very open-ended question.
Yeah.
So the Scala community.
How's it going, and how do we improve it?
Well, it's definitely grown a lot bigger. There has been some drama in and around the Scala community, which is not that great, but all these things just happen. What I find we should change, or where we can improve, let's put it that way, is sort of a transparent, open collaboration of many parties together around essentially more fast-moving open source things. So essentially, we currently see there's TypeSafe, who's sort of the keeper of the Scala stability for the enterprise, which is very much needed. So essentially, they're sort of the backstop that makes sure that things don't go completely astray. But beyond that, the community efforts, so there's type level, there are many others, has been a bit, how would I say, a bit, fractured. There are many factions, there are many different efforts, and there's not a lot of collaboration between them.
People working against each other maybe a little bit more than we could do.
Yeah. If I compare, let's say, to Spark, which I think is an example of a very successful community, so Heather spent some time in Databricks and told me about that, how that was. Heather, maybe you say how it works in Spark.
Well, I mean, it seems like, okay, I can't give you like concrete numbers right now because it seems to change from month to month, but let's just say, so every month they have at least 100 or so contributors, different people that are contributing, like from, you know, whatever, different companies. They don't have that many people at Databricks, of course, which means more people than not seem to be contributing from other companies and other just people interested in open source, people who actually need Spark for their day job and need something like added to the library or fixed somehow in some way, and they are ridiculously active in terms of like merging pull requests and interacting with people, and as a result of that, we have like really a super sort of together community where people are using Spark day to day, and then you know, contributing back stuff kind of very, very fast and all the time. And I mean, as a result, it's like I mean, Databricks has, you know, something like 300 pull requests in their queue at any given moment, and like the number of pull requests that they're merging daily is incredible. And as you know, it's so basically they have this very together community, which like at this point it's very interesting to look at because it's going to be a matter of like human scaling now. Can we manage all of these people sort of and merging all these pull requests and whatnot? I mean, we would like to get somewhere maybe in that direction in terms of people working a little bit more together, contributing more things back. Because we seem to be like a little bit the inverse of that. We have more people, it seems like, I don't like this library, let's just make a brand new one and then like, you know, fight against it or something. It's like, why don't we all kind of work together maybe in some sort of, I don't know, like more excited kind of together way to improve things for everyone, right? Instead of maybe waging all these wars with each other. It seems like, at least this is what it looks like from my perspective, and there's a big difference when I was there and seeing how just everybody, like random companies, you know, that you would think that are like super enterprising are like they have one guy for half a day like fixing a Spark bug and contributing it back, and it's like, all right, but we don't seem to have that much going on, that kind of stuff going on as much as it is in Spark's world and the Scala side of things, which is a pity.
Well, I should say that this is not absolutely not that the Scala compiler team would not want contributions. They very much invite contributions, and they're very, very keen to get them. I think the problem is that the setup, like what I said with binary compatibility, it just takes so long to get anything rolled into the standard Scala release. So you have to be very, very patient, and that's sort of something that is unavoidable in a sense. So I think we have to create some new structures to get this sort of excitement and collaboration going.
Yeah, I mean, collaborating on a language is hard, and it's not even just the longer feedback cycle, right? I mean, if you want to collaborate on Spark, you grab the project, you install SBT, I would assume, and then you just go, right? And it's just like
an operating system nowadays, by the way.
Oh,
there
is
are
it really?
lots of libraries built on top. Everybody is using Spark as like a middle layer for things. It's really incredible. You should look. They have like a Spark packages now. It's amazing. You should have a look at it.
Holy cow!
Yeah,
well,
yeah.
I imagine it's still not quite as crazy as like downloading Scala and putting Ant back on your system because it's like 1990, and doing the bootstrap build. Like I mean, building Scala is hard, so I'm not like indicting the Scala core developers or anything like that for not making this better. But it's very difficult to contribute to Scala from that perspective because there is a lot of overhead. And like once you do that work and once you understand how it works, it's not that crazy, but it's still it's not the familiar pull, SPT test, push, and pull request model that everybody else has.
By the way, Spark has a crazier build than Scala, I think, by far.
That's considering that Scala's Ant file it takes advantage of the Turing completeness of Ant. I think that's quite the claim. What on earth are you doing?
I hope you don't get in trouble with Databricks for saying that.
No, it's open source. Just have a look at the build files and whatnot and Apache Spark. It's very. I'm amazed, by the way, with Patrick for doing this. I don't know. It's incredible.
It's certainly true that, let's say, to hack the Scala type checker, you have to have a lot of experience and a lot of knowledge, and not everybody can do that. But I think there are lots and lots of other parts which are very open to contributions, from the library to, let's say, what came up Scala parser combinators. They're just too damn slow. So, I mean, they were at the time, essentially, when the Scala library was born. I mean, we had maybe a dozen users or something like that. So something went into the library because somebody wrote it. That was the only criteria, right, at the time.
such as Derek Chen Becker's JSON parser that he didn't even realize was going into the library until it was already released.
Yeah, of course, it was a nice recognition. We put it in the library, right? But for a dozen users, that's what you would do, because I mean, you're glad that about every bit there is. But the point is, of course, we can get to work on it, and of course, we can make it faster, and we can even maybe break things in a controlled way. But that's the sort of things where we need the community. I mean, you can't just say, and the type says the team is predominantly the compiler. You can't hold them responsible for every bit in the standard library. So that's sort of things where I think contributions would be great, and we need more of them. Or to hold you here, since I have you on the line, Daniel, what about this anti-XML thing?
Oh,
wow.
That's right.
Oh, yeah. So that's actually, without digressing too much, that's actually being it was taken over by why can't I remember his name? Jan Anders company, Jan Anders consultancy, because they used anti-XML a lot, and I mercifully, like, I was no longer working on problems that touched XML. And so I kind of stepped away from the project a little bit, and they kind of took it over.
Okay.
But it is being maintained, and it is there, and it actually has like correct semantics for namespaces and validation and things like that, and still has like the exciting zippers and things like that. So yeah.
All right. Yeah. Okay. But if something like that materializes, I think it would be good. It would be great. And I think part of what we need to do for that is to arrive at a sort of a more modular notion of what a standard library is. So
yeah,
must be clear that this is not all baked in stone, that there's some core modules that we back and say, well, those will remain stable for a certain time window, and others should be able to move faster. And I think the Scala team has modularized the library a little bit, and this is great. It's a lot of effort, but I think parser combinators are now their own modules, and actors are their own modules. I don't know whether XML is. I think XML is its own module.
XML is its own module now. Yeah.
From now on, I guess one can actually.
Well, you can sort of, because you can't actually you can't hijack the XML literals, but the XML literals are going away, so it's sort of okay.
Yeah, exactly. Yeah.
So I think we're running short on time. Do we need to wind up now, or do you have time for one more question from a viewer?
Yeah, let's take one more. Yeah.
Okay, so two people, Runar Bjarnason and Gabriel Campero, are asking about the work on lightweight modular staging. Runar asked, could you talk a bit about the modular staging work and whether the Scala.meta project will give us staged compilation?
Okay. So, right. So the staging work is essentially, the idea of the staging work is that if you write some code, typically in a DSL, then that code will actually, when it's first run or loaded, it will construct a representation of itself rather than already starting execute the program. And then you will have essentially a runtime compiler that will then take that thing and turn it into code, but hopefully code that's more efficient than the standard code you could do. But that code can be more efficient because you, at runtime, you can do a lot of inlining that you wouldn't dare to do at compile time, because you wouldn't, your target might be not statically known, or you might again break binary compatibility. You know what platform you're running on, so you know whether you're massively parallel or not, and you know the problem size, so you already get essentially the input data, and you can essentially optimize with all these parameters, and that way you can do a much better job than at compile time only. So currently the lightweight modular staging uses types very heavily to achieve that. So essentially we have two levels of types. The normal types like int and string, and then there are the representation types, which are, there's a type constructor called rep for representation, so that's rep of string or rep of int. And representation means if a function, let's say, returns a representation of string, then what it returns will be an expression tree or data flow graph that will, when it's executed, give you a string. So rep of string really means a data flow graph that will give you a string when it's executed. And that is very elegant, and it gives you a lot of flexibility, but the users have found it sometimes difficult to wrap their head around these types, because in addition to the types, you also need a lot of implicits that essentially then reconstitute the right semantics on the rep types. So, for instance, if I have two ints, then of course I can add them with a plus. So now I need to actually inject the plus also as an operation on rep of int plus rep of int, because of course I want to write the rep level functions in exactly the same way as the normal functions. And it turns out, well, this gives you a bunch of implicit conversions that you need, and that of course makes the whole thing pretty fragile. And it also makes the whole thing sometimes spectacularly slow to compile. So I think on some code, people have seen compile speeds of maybe 10 lines a second or something like that. So really, really, really slow. And so there's a number of efforts going on that say, well, can we have sort of a more a simpler front end that would still use the types in the back end, but in the front end we would have something simpler. There's Yin Yang and there's Scala Meta that tries to do that. So essentially, have the same thing, the Scala, the lightweight modular staging, but in a package that's more digestible to near humans as users. And we'll see what comes out of that. But currently, there are a lot of things in flux. So papers are being written, presented at conferences. No clear winner has emerged yet, I would say. That's the current status.
All right. Anyone have a final thought before we call it a show?
I just want to say thanks for joining us, Martin. I know you have a really busy schedule, and I know you're in crazy European time, so you can't interact with those of us who are on a sane solar cycle, and it's been really great. I wish we could do this sort of thing more often.
Yeah, I had lots of fun. Thanks for having me. Actually, we actually have a Christmas party that has started here, so we probably should join that now.
It's much more important.
Yeah.
Yes.
Yeah.
Not all about that.
Yeah.
All right.
All right.
Take care.